Summer interns at Savannah River National Laboratory in South Carolina are taking part in research to differentiate mercury species using two new technologies: diffusive gradient thin film samplers and microcolumns. Sponsored by DOE's Environmental Management Office of Technology Development, these technologies incorporate targeted chemical reactions to differentiate key mercury species, while reducing analytical cost from about $1,000 to $100 per sample.
Okay.
Do you have any questions?
Mercury is important to DOE because a lot of the old legacy sites like SRS, and especially up in Oak Ridge, have a lot of mercury that's made its way into the sediments, and so we need to keep an eye on how much is in our streams, what kind is in our streams, because certain types of mercury are more dangerous than others.
So this is our third year of pursuing this. We had ambitious goals to both fabricate samplers, take them to the field, deploy them at both Oak Ridge and Savannah River, get them back and analyze them.
Mercury contamination is the primary reason for fish consumption advisories in all 50 states. High mercury concentrations are also present inside legacy radioactive waste tanks at DOE complex sites.
It's important to industries all over the country. It's important to environmental agencies. Virtually every outfall in every stream is analyzed for mercury.
Of particular concern is methylmercury, a highly toxic organomercury compound that has the ability to bioaccumulate at higher concentrations in tissues of aquatic life than in the water, then biomagnify and become even more toxic as it moves up through the food chain.
And what we were trying to do was develop a sampler that would measure the different species of mercury, because for mercury, the species that exists in either waste or the environment is a key to how it behaves, how you can remove it, or its toxicity, how much builds up in fish. The breakthrough of our diffusive gradient samplers and our microcolumns is the innovative use of the reagents for reducing and amalgamating the forms of mercury that we want to take out and leave in the forms of mercury that we want to analyze. The interns worked together and they actually fabricated all of the reactive diffusive gradient samplers. So the diffusive gradient sampler has several layers and each has a certain purpose. So there's a filter on the outside that just protects it. Then there's a diffusive zone that controls the rate that mercury accumulates in the sampler. Then there's a collection zone. We've added reagents either to the diffusive zone or the collection zone to basically push mercury around and bend it to our will.
After fabricating the samplers, the interns then deployed the DGSs into the waterway at Oak Ridge National Laboratory and the Savannah River site. After a specified time, the samples were collected and taken back to SRNL for analysis.
Well, we're looking at the same chemistry in microcolumns because we want to give ourselves the maximum chance of having success and having diverse solutions that come out of the laboratory. So once we got the samples back to the laboratory, the microcolumns would go onto a shaker table. Then we would simply filter out the sorbent that we had put in there.
No matter the species being sampled for, both technologies can utilize a standard total mercury analyzer as the final step. The simple and inexpensive technology has real-world commercial and research applications in environmental monitoring, aquaculture, and equipment manufacturers and suppliers.
So we actually have 2 patents that have been applied for, one for microcolumns and one for diffusive gradient samplers. We've had several companies contact us with some interest in licensing the technology.
The Mercury Speciation research at SRNL is also providing valuable hands-on experience to the next generation of scientists.
We recognize that we have so much to learn, and it's good to get firsthand help from a mentor. So.
And Brian's a great mentor.
Yeah. I want to say the biggest takeaway, besides obviously learning more about mercury and how it interacts here in our environment, is really just doing hands-on work, because I love hands-on work. And I got to see what actually having a real job in the lab would be like, and I'm graduating soon, so it's good to see what I can aspire to do in the future.